Okay, this is my prototype workout energy generator. This is the Mark 6. I don't know if you can see that. Mark 6 V6. This version has a few differences. One, where it finally solves the interchangeable resistance system issue. This model actually implements it with a belt drive, so no hardcore axles touching each other, which is really nice. So I can actually change the resistance of the system for muscle training, for specific muscle groups, if you will. So this model is compatible up to 10 to 12 overdrive ratios. The one in my hand is a 12 overdrive ratio. So for instance, if you wanted a lighter workout, you go with a 10. If you wanted a heavier workout or more load workout, you go with a 12. The difference between energy generation, however, with this model and the other model is this one is slightly lower. So in my previous model, I calculated the voltage generator at a certain RPM that I measured from experiments. It was around 5 volts, but the issue with this model that I didn't take into account is I increased the capacitance of this model by a lot because I thought it would do better with the voltage ripples and give a more stable output voltage. However, what I didn't take into account was the input charge equals the rate of voltage divided by the change in time times capacitance. So because I increased the capacitance and because the average energy I'm putting into the system is constant, the rate of voltage changing over time is slower. It basically means that the voltage rising is much slower. And we can show that today with a multimeter. So if I put the probes of the multimeter up to the capacitor, I actually did a few workouts before on this machine, and it's reading, I don't know if you can see that number, 1.73. We're going to put some energy into the machine and see how the voltage changes. So here I have a 12-time overdrive gear. I'll show you how I put it in. You align the belt with the teeth, put it over the idler tensioner, and the idler tensioner helps keep everything engaged, which reduces slip. Of course, there's still going to be slip. The idler tensioner is meant to be like a plug-and-play system where you can adjust it as freely as you want. Slip will always exist in this type of system, but that's fine. The next prototype will aim to allow higher levels of tension, but overall you can see how it helps keep all the teeth engaged with all the tooth. And this is how you plug it in. As you can see, I push the axle in, put it down, there you go. Now it's ready. Ready? 1, 2, 3. Sorry about that. It does like its slip. As you can see, this trains my biceps. And like I said again, it always likes to slip. Overall, the system's not perfect. There's still a lot of improvements that I'll need to do, but again, occasionally this will slip, so tension needs to be adjusted accordingly. And now the number reads 1.7. Oh, let go. 1.7, 1.6. So as you can see, the voltage rises very slowly, but the capacitor does absorb the energy. And if you compare it to the last prototype where the voltage spiked up really high, especially when I pulled it really hard, it spiked like crazy. There was crazy energy. Well, that was because there was less capacitance at the time. So now realizing my drawbacks with this version and the upgrades that I was successfully able to implement, I've been learning PCB design, and my hope is to essentially incorporate the rectifier, the capacitor, and the buck converter into this all-in-one circuit where it's multi-compatible with multiple different motors for better testing, because all these calculations were done on a notebook and an Excel sheet, which is fine, but they're rough calculations, rough approximations. I feel like if I could record live data, it would help me better approximate a better motor and possibly make a 3D printed motor for a future prototype. By incorporating all of these, I could easily adjust the output voltage, screw in different motor sizes, and have a better constant output of voltage, more constantly, if you will. And now that I know that the interchangeable gear system works, I will be implementing a better version of this for the next prototype, hopefully, to allow all the way up to 6 to 12, which is the hope. But Yeah, I've been learning PCB design, and I'm hoping I can incorporate this skill into the next prototype, which hopefully works out to be all right. But overall, this is the machine. Leave me any comments if you guys want to know something about it or what I could do to make the next version much better.